Hi guys, Happy New Year. We were fortunate to end a chapter right before we went into winter break. So you guys have been taking the NWEA the last couple days, and now we're going to move on to chapter 5. My goal was to test over chapter 5 before the semester exam, just to give you one more test in there to help you guys out. I think this is going to be a pretty easy chapter for you. I can't guarantee that, but that's my goal. So, the title of chapter 5 is Congruent Triangles. So we're going to learn lots about congruent triangles, the tricks of them, and all the different patterns that will come into contact. So, on this notes page, stuff is kind of going to be all over as far as notes, assignments. I'm still going to use Go Formative for all assignments, but I don't really have a note packet for you because this is a chapter where we would typically do a ton of proofs. I'm going to do a little bit of proofs, but nowhere near, they won't be anywhere near as intense as they have been in past years. So I'm saving you guys a little bit there. So congruent triangles. Congruent triangles are triangles with the same shape and size. They're going to have the same area, the same dimensions. This means if they are congruent, then all of their corresponding parts, so the angles and the sides, are congruent. And this is what we're going to talk about. I'm going to tell you what this means all throughout. The word corresponding is going to come up a lot because we can tell what pieces are congruent to what just by how we write the names of these triangles. So you're going to write a series of congruent statements this semester. This here is a congruent statement. It says that triangle ABC is congruent to triangle DEF. So in a valid congruent statement, it must match all corresponding angles and sides. What that means is I wrote the name of this triangle as ABC. I said that it was congruent to DEF. The order that I listed these tells me what's congruent to what. So since A was listed first, angle A is going to be congruent to whatever is listed over here first. It's congruent to angle D, and etc. Angle B is going to be congruent to angle E. Angle C is congruent to angle F. Now the sides work the same way. Remember, we name a side with 2 letters. So we have side AB. AB is going to be congruent to DE because AB is first, DE is second. So I could actually cover up this set of triangles and just go off of this. AB is congruent to DE, BC must be congruent to EF, and then CA is also congruent to FD. Okay, so that's what I mean by corresponding. They're in the right spot. So we're going to talk about CPCTC, which is kind of fun to say. But what it means, or what it stands for, is that corresponding parts, so CP, of congruent triangles are congruent. So not only are the triangles as a whole congruent, all of their individual pieces are congruent to something on the other triangle as well. So if we know that 2 triangles are congruent, then we know that every pair of corresponding parts, sides and angles, are also congruent. So we're just going to start by listing out all of the angles that are congruent, all the sides that are congruent to this right here. So the angles, I'm just going to go through, I'm going to go in this order. Angle J is going to be congruent to something, angle K is going to be congruent to something, and angle L is going to be congruent to something. So angle J is going to be congruent to, well, we have first to first, angle P. Angle K is congruent to angle Q, and then angle L must be congruent to angle R. JKL, PQR. We maintain that same order. Now the sides. JK, this first side here, is going to be congruent to PQ. KL is congruent to QR. And then finally, JL or LJ, doesn't matter, JL is going to be congruent to, so first and last is congruent to first and last, PR. So those are all the angles, those are all the sides. Now they want us to write another valid congruency statement. Students get a little confused on this, but really there are 3 ways to write this. Okay, they picked this particular order. I can write another congruent statement, triangle. Let's say I want to go KLJ. So I just said KLJ. That is going to be congruent to triangle. Well, I can't leave it PQR because these switched up their order. So what was in the same spot as K? Q. What was in the same spot as L? R. And what was in the same spot as J? P. So the other one would be, you could start with L. Okay, there's several different ones that you can use. All right, so I'm not going to go through that same example again. You guys get the picture. Number 3 here, it said, given that triangle KPM is congruent to triangle AYC, complete the following statements. So KM, you can use the picture if you want. We could go through, we know that K is going to be congruent to A. P, I'm going to double up the arcs there, is going to be congruent to Y, which leaves M congruent to C. The sides work the same way. KP is congruent to AY, going off of the order. PM is congruent to YC. And MK is congruent to CA. So I don't like to use the pictures. To me, that's a little bit more confusing. I just like to go off of the order. You can do it however works for you. So KM, first and last, is congruent to first and last, AC. CY is going to be congruent to MP. Then we have PK. PK is congruent to YA. What about angle Y? Angles are easy. Angle Y is in the middle. Angle P is in the middle. Angle K is first. Angle A is first. Now they wrote an angle in the other way that we can write it with 3 letters. They said AYC. So AYC is congruent to AYC. Well, that's congruent to angle KPM. Or excuse me, KMP. So I messed up there. ACY is going to be congruent to KMP. What about triangle? So these are our congruency statements. Triangle, MPK. MPK is going to be congruent to triangle. So we went MPK, we're going to go CYA. And then YAC, you can do it on here too. YAC is going to be congruent to triangle P, YAC, PKM. And that's it. All right, so we're going to go ahead and flip through. I'm going to do a couple more examples with you guys. On number 4, they wanted us, we're going to do actual measures. Okay, so we're going to have to do a little bit of math, but most of it's just picking off of here. We know that triangle STW is congruent to triangle BFN. All right. So let's label things. WS is 9. WS is congruent to NB. So this over here is 9. We know that TS must be congruent to FB. TS is 17, so FB is 17. Now the other side that's missing here is congruent to this FN. So if this is 14, this is 14, and that accounts for, that's all of our sides. Now the angles work the same way. Angle S is congruent to angle B. So angle S is 67, B is 67. Angle N over here is 82. Sorry, N is 82, so W is 82. Now we're missing both of these angles on this triangle. Well, back a couple chapters ago, we learned that all angles inside of a triangle add up to 180. So if we know 2 out of the 3, we're just going to subtract 180 minus 82 minus 67. 180 minus 82 minus 67 is equal to 31. So each of these are 31. Now we can go through and answer all these questions easy. BN is 9. TW is 14. BF, 17. Angle W, 82. Angle B, 67. Angle F, 31. And that's it. All right. So we are not going to do angle 5 or triangle 5 here, or question 5. Down here, they're going to throw some algebra at us. They want us to find the values of x, y, and z. So they tell us that this triangle here is congruent to this triangle here, so let's use that. If I want to find x, okay, x is right here. It's on UV. So if UV is 12x minus 7, UV is going to be equal to whatever TS is. So TS is 53. So we set it equal to 53. We're going to add 12x equals 60, divide by 12, x is 5. Now let's do the same thing with whatever is on the y. We have 5y minus 33. RS is congruent to WV, so it's equal to 57. Add 33, add 33. 5y equals 90. Divide by 5. Divide by 5. Y equals 18. Now we can do the same thing with our z. 3z plus 14. UW is congruent to TR, so it's equal to 50. Subtract 14. 3z equals 36. Divide by 3. Z is equal to 12. So do you see how we used our congruent triangles to find the rest? These over here are going to work the same thing. They're just angles. Now down on number 8, they only give us these, okay? So we have to match them up. It's not as visual. You can, if it's helpful to you, draw out the triangles and label everything. But I kind of like to go through, I want to find out what DF, well, I want to find this x. DF, we have a 9x minus 23. So if DF, I need to find information somewhere about JL. So if I scan through here, I do know that JL is 7x minus 11, so those two are equal to each other. So 9x minus 23 is going to equal 7x minus 11. So we solve. We get 2x minus 23 equals negative 11, add 23. 2x is equal to 12, x is equal to 6. And finally, JK, I got to find this y. 3y minus 21 is JK. Well, JK is this, so it must be equal to DE. So I look, I only have 2 left. Which one is it equal to? It's equal to the 18. So add 21, 3y equals 39. Y must be 13. And that's it. All right. These have a little more angles. So like I said, if you want, draw out the triangles and label everything. And then that puts us in this situation here where you're just looking. But using this is super helpful. This is the key. The order of those will tell us what to set it equal to. All right. Good luck, guys. Have a great day.